Okay, I can do that. All right, let's see. So the start as in just welcoming people, I guess. I should have asked before the recording started. But anyway, all right, I can do that. Welcome everyone to the information session for the CDS's PhD program's medical track. If I recall correctly, the oldest conversation between the CDS and the School of Medicine began in late 2015, shortly after I joined NYU. I literally just came down to a radiology department and then knocked on a few doors. Unfortunately, some of the faculty members there actually answered my knocks, and then we started to have some conversation. In particular, Professor Linda Moy of radiology really welcomed me kindly. And the first step I took back then was to hire a postdoc to help me start this new endeavor. And the postdoc, Christoph Garras, has become a professor, Christoph Garras, at the radiology department since then. And then he is also one of the faculty members who participate in this medical track of CDS PhD program. And he actually is supervising several PhD students on deep learning for medical imaging together with me. And now, fast forward 7 years, we now have a full-blown track at NYU CDS PhD program to train PhD students at this exciting intersection between data science and medicine. This program started only in fall 2020 with an initial cohort of 4 students. And now we have 8 PhD students in total, involving faculty members from both CDS and School of Medicine as well. And this is also part of the fast-growing and vibrant CDS data science PhD program, which started again only in fall 2017, but we already have 52 students in program and have graduated 9 students with their PhD degree in data science. So very happy to see everyone who expressed their interest in this exciting program of ours. And I hope that you all will share my excitement after hearing from our excellent faculty members and even more excellent students. So welcome, and I'll pass the stage to Professor Dan Sodickson from the NYU School of Medicine.
Terrific, thank you, Kyunghyun. And I think, great. Okay, so hello there, everyone. I'm Dan Sodickson. I serve as Chief Innovation Officer in the Department of Radiology at NYU School of Medicine, and also as co-director of an institute called Tech for Health. Both of these enterprises are in dire need of good data scientists. So as a consequence, and because more and more areas in medicine and technology have been looking to modern AI for key new advances, I've been part of ongoing initiatives to foster robust connections between the Center for Data Science and the School of Medicine. And Kyunghyun told you about some of the earliest connections. I learned of that particular connection relatively early on, and then I've had the pleasure of talking and even publishing with Kyunghyun and colleagues since then. I'm here this morning to just say a few words about why you should pursue the NYU CDS PhD medical track. And actually, I have 6 words for you in particular. The first is problems. Basically, my argument to you is you should pursue this track because we have lots of problems. What I mean, of course, is the good kind of problems, or at least good for you. I'm talking about unsolved problems and unmet needs in biomedicine. So how to preserve brain function with aging, how to predict and prevent cancer and arthritis and heart disease, how to detect subtle changes in an individual's state of health. It's well known that a problem-rich environment fosters innovation. And in fact, people have said that Bell Labs, which brought us the transistor and the laser and the telephone system, and arguably some might even say convolutional neural nets, didn't just have the best solutions, they had the best problems. Their scientists were immersed in a problem-rich environment and then allowed to follow their noses in previously unimagined directions. So that's problems. My second word is people. And the bottom line is there are a whole lot of smart and motivated people who are waiting to work with you. There's a real hunger for data science in general here at the School of Medicine. And there's a rich ecosystem of departments and centers that are working on it now. So if you join this program, you'll have mentors, colleagues, people with diverse training and perspectives all around you who are eager to be working with you. Third, you'll benefit from a range of powerful partnerships. So of course, there's the foundational partnership between CDS and the School of Medicine, but don't forget that we have the Tandon School of Engineering, which is also very much in the mix. And there are lots of people interested in data science methods attached to engineering problems and new devices. And here in New York, we also have other great partnership opportunities. So for example, just a few years ago, I found myself with an initial tip actually from Kyunghyun, working closely with Facebook, now Meta, on a project to speed up MRI, strangely enough. And the CDS also has strong connections from very early on with Facebook as well. And then of course, the New York area is home to any number of big tech companies or small startups that are engaged in this general area. Fourth, then, I guess it gets back to the name of the program. You would be training to be data scientists, and for that you need data, right? And we have data at the School of Medicine. We have gobs and gobs of data. So just in our Department of Radiology alone, we perform more than 2 million imaging examinations per year, many of which individually encompass thousands of individual images. And that's just radiology. There's also our medical health record, and our pathology slides, and our population health studies, and our hospital operations, and on and on and on. So data to be had all over the place. And then for data science, of course, you also need science. And in this case, I'm referring to key domain expertise, without which machine learning, for example, is really operating blind. And so in this program and at the School of Medicine, you'll find experts in genetics, and in imaging, and in ophthalmology, oncology, and really everything else under the sun. And then finally, and arguably most important of all, there's impact. You obviously have a choice in how you apply your data science acumen. Biomedical science, I would argue, is an area of great need and also great import for the day-to-day welfare of humanity. A couple of years ago, for example, when I was giving this introduction, I spoke about the potential to make a difference for the COVID crisis. And in fact, that potential was quickly made real by a number of faculty in the program. This year, I'll cite another illustrative example in my own Department of Radiology. We're hard at work now on developing the medical imaging scanners of the future and transforming the future of scanning. And at the heart of this initiative, perhaps not surprisingly, are groundbreaking new developments in machine learning, which can help detect early changes in the health of our patients, or can bring the benefits of imaging to people wherever they may be, in underserved parts of the world, or even at home or at work. So we currently have, in fact, a new first-year CDS medical track PhD student, Arda, on that team, and he's diving right now into some interesting problems in representation learning that we hope will end up making a positive difference for people around the world. But don't just take my word for it. You'll be hearing next from Tina with some key practical information, and then from a faculty panel made up of 3 colleagues that I can tell you from experience are great to work with. And then last, you'll hear from a panel of student pioneers in the program, including Arda, whom I just mentioned, and 3 of his colleagues, so you can assess their experiences and their accomplishments for yourself. So I guess I'll just say welcome once again to our open house, and it's a pleasure now to yield the floor to a group of people who together are really shaping the future of health.
Thank you, Dan.
You bet. Oops, I just need to, good.
I'm Tina Lam. I'm Assistant Director of Graduate Programs at CDS, and I'll be moderating the panels. And before we head into that, I just want to quickly give one slide with basic information about admissions and applications. Our fall 2023 online application is now open. This session will be mainly for the faculty and students to hear from their perspective. So if you have questions about general admissions or application issues, I guess, please reference the website and then email us at cds-admissions@nyu.edu. If you have questions for the faculty and the students, please do enter them into the Q&A and we'll address them as we're going through the panels. So with that, I would like to welcome our faculty panelists, Kyunghyun, Patricia, and Eric. And I have some prepared questions, but if you would first please introduce yourself and your background or research focus. And I'll stop share so we can see your faces. Maybe we will go backwards. So Eric, please.
Sure. It's nice to meet everyone. I'm Eric Oermann. I have kind of a meandering career where I dropped out of the PhD program studying group theory to then pursue this weird education through medical school. And then I took time as a postdoc to work at Google, where I worked on the Google Watch and GANs, followed by some time at Google X as an advisor to Project Amber. And then I went back and trained as a neurological surgeon. And so at NYU, I have both a neurosurgical practice, as well as a computer science lab, where our interests are mainly in translational research, as well as trying to use our unique access to the human brain to make better AI.
Thank you, Eric. Patricia?
Hi, everyone. I'm Patricia. I am faculty in radiology. I work closely with Dan Sodickson. My background is physics, actually. Now I work in MRI. Mainly my focus is on developing deep learning tools for accelerating MRI scans. They can be quite long, which makes them expensive and somewhat tedious for patients. So deep learning tools for accelerating MR scans, also monitoring disease progression. So generally kind of MRI and deep learning tools for applications in prostate cancer and musculoskeletal imaging.
Thank you. Kyunghyun?
Yeah, hi everyone. I kind of gave a welcome remark, so it's a bit awkward to introduce myself at this point, but I'm an associate professor of computer science and data science. So I'm at Center for Data Science and also at the Korean Institute of Mathematical Sciences. And I'm a deputy director of the Center for Data Science this year. And I also hold the position of the senior director at Genentech, nowadays working a bit on how to use deep learning for antibody design as well. So it's my kind of, let's say, big interest to see how these machine learning algorithms can have impact on various problems that involve the healthcare as well as medicine. So, welcome everyone.
So the first question I have is, when you're considering applicants to see if they're a good fit for this track, what are you looking for in the applications?
I can go first. Yeah, I have had quite a few students in this track, as well as even earlier on when the medical track wasn't here. But the students actually did work on some of these medical imaging related problems. And one of the important aspects that I see when I read the applications, in particular when I read the statement, is whether the students are ready to dedicate their effort and time on problems that are not necessarily easy to tackle, but challenging and will eventually have a big impact. And it's actually not easy to find so many students who can express this kind of their desire to spend enough efforts and invest their time to work on challenging but impactful problem, because often that's like literally challenging. So the important thing is, it's both in a sense that you should be ready to dedicate a lot of time and effort in order to solve these impactful problems to apply to the program. But when you do so, you have to ensure that that kind of desire and that your desire is actually shown or expressed in your application as well.
I can sort of follow up, Casey, that similarly, I think that passion for scientific inquiry is maybe the number one thing. I think everyone here enjoys doing scientific research. And so we look for people who will enjoy doing it with us. And I think for me, kind of the hallmark of being ready to tackle those hard problems that Casey was alluding to is proof that you have a strong engineering skill set. They can write good, clean code, you can debug it. I think those engineering, sort of the fundamentals of software engineering, to me is what says that you're kind of ready to proceed as a scientist, where sort of the guardrails are off in many cases. And having those strong fundamentals is important to success.
Yeah, I agree with Eric and Kyunghyun. So I'm new faculty and I've only had one iteration of kind of reviewing applications, but certainly something that has stood out to me is in the statement of purpose, just being able to see that your research interests are aligned with my own, with the interests of the department, that you have kind of the fundamentals, so demonstrated coursework in data science, in stats, and you have that fundamental background. And just, yeah, that your interests are aligned and that you can kind of communicate your research interests effectively as well.
Got it. So another question that we get regularly is, do applicants need to have relevant research experience if they have the interest right now for the medical school track, but don't have relevant research interests? How should they proceed with the application in that case?
I don't think it's necessary personally. Again, I think if you have a passion, if you want to use computer science to improve human health and you have the strong fundamentals, I imagine everyone would be excited to work with people with that background. I don't think you have to have done research in this area prior to taking a crack at it.
Yeah, absolutely. I mean, it's kind of difficult to have the research experience in this very particular area. And there is a reason why we created this medical track at Stanford Data Science together with the School of Medicine. So the direct relevance is probably not the thing that we are looking for, nor will be able, is easy to come with. But of course, having some research experience in diverse set of fields, I mean, that never hurts. That never hurts. But that's not like the thing that's going to make or break the application.
Yeah, I think any research experience is a really big bonus, but not essential.
Got it. So prospective students regularly also ask us, like, based on my background, is this program appropriate for me? And in particular, we have a question in the Q&A right now where this person states that they've been working in clinical trials for the last 6 years in the statistics department. But they don't have they have a lot of healthcare background and they did their master's in data analytics, but they don't have computer science engineering background. They want to know, like, what are their chances of getting into the medical track and what advice would you have for them?
That is indeed a very difficult question to answer. But then the thing is, we can actually go beyond, let's say, medical track, and then I can talk a bit about the Center for Data Science itself and its PhD program. So of course, traditionally, if you wanted to work on machine learning or more broadly artificial intelligence, and with the, let's say, focus of medical imaging or any kind of medicine related stuff, your options had been either go to the statistics department, go to the computer science department, or go to the medical school, and then trying to go into the PhD program there. But none of which has had an advantage of training students to look at all different aspects of these programs. So we had to essentially create a Center for Data Science to build an environment where we can train PhD students to be able to look at all these diverse set of aspects into the one problem that is let's say, data science for X, right? X could be, let's say, healthcare, X could be medicine, X could be natural language processing, or whatnot. So let's say if you have experience, let's say, working on, let's say, clinical trials, from the statistics department, that already covers one of those aspects that we want to train our students on. And hopefully what can happen is that such a student joins NYU Center for Data Science, the medical track, then we will be able to provide all those complementary, let's say, coursework, as well as the other, let's say, advices, so that the student can quickly catch up on those missing aspects that they would need in order to be successful as a PhD student down the road. So the answer is yes, we have created this program to be able to accommodate students of the diverse set of backgrounds. And then it sounds like an experience working on the statistical aspects of the clinical trial already is a good starting point.
Thank you, Kyunghyun. So another student has a question: is the medical track more competitive than the non-medical track? If so, how many students do you usually take in every year? And I understand that this varies, but if you guys have any comments on it, or I can say a few words if needed.
Tina, I think you can just give them the numbers
Yeah.
directly. Yeah.
Yeah, so it's not really that we have like a set number of like medical track students that we want to admit in 1 year. It's really whether the applicants have a good fit with the faculty who are looking for PhD students. So we don't really have numbers on that, and that's why the numbers have varied in the previous years. It's not necessarily that faculty weren't looking for students, but they just didn't find a good fit in previous years. As for whether medical track is more competitive than non-medical track, there is no real competition. Again, it's whether it's a good fit. So we have faculty in the medical track and in the non-medical track, and they are looking for students and reading through the applicants and just seeing who's a good fit for them. This attendee had a follow-up question. Once you're in the medical track, will your research be constrained to only healthcare related topics, or would you have the option to explore general ML topics as well?
I think some of that ties into what Tina was saying earlier, that really the most, and this is maybe good career advice for everyone, that your fit with your mentor, be it your thesis advisor, or maybe someday your manager at a company, is one of the most significant things to guide your success and your well-being and your happiness. And so really I think that's what we're all about to some extent, is finding people who have a good fit, because that's what's going to make everyone happy and successful. And I think as students, like really your big question when you're applying to programs and looking for thesis advisors is, who do you fit well with on a personal basis and a scientific basis? I know that, I think for me and KC, we're completely happy, if I can speak for him, we're completely happy pursuing even non-medical topics that are more theoretical. I know we had a reinforcement learning project last year where we were playing Sonic the Hedgehog. But the students were really interested in it. I was interested in it. And so we kind of mutually agreed on, like, we were going to tackle that together. But I think because we all had a good fit, similar scientific priorities, it was a very natural transition for that line of research.
So we get another question a lot, is how should applicants approach faculty or advisors during the application process? Should they be approaching? And I know every faculty is kind of different about that. For you guys, what would you guys prefer? Should someone reach out to you, and in what way or how should they reach out to you?
Patricia, how should students approach you? Yeah.
So how would they approach me, like, regarding applications?
If they were interested in working with you, I guess, what would you want them to write to you about, or what are your requirements?
Yeah. I think, again, I think it's important that, your research interests are aligned with mine. So I always look at, your statement of purpose. If you reach out to me, certainly just let me know specifically kind of what kind of projects you're interested in, a little bit about your background. I'm always happy to get on a Zoom call and have a conversation about it as well. But feel free to reach out to me if you have any interest really in applications of deep learning to MRI, to medical imaging, and we can definitely chat about projects that would be a good fit.
Eric, do you have a preference, or?
Yeah, I feel like I pretty much like reach out to me by email. Fairly communicative by that. Certainly, if you have my cell phone, text me. Yeah, I think just reaching out, and like you always find the time to talk with people. Because again, I think especially for me, like having a chance to interact with people, especially on an informal basis, and try to find a good fit is really important.
Thank you. I want to move on to the student panel. So one last question or prompt. If you were to offer one bit of advice to applicants when they are putting together their application, what advice would you have? And so our application requires a letter of references, a statement of purpose, the previous transcripts. Are there any bit of advice you want when they submit these?
I can go first. I can say just two things. One is that we actually do read every application. We don't really have any automated or the kind of templated way to filter out any of those applications. So every application should be put really carefully and thoughtfully. And then there's no, let's say, parts of the application that can be overlooked or anything. That we really literally read everything from the first page all the way to the final page. And second thing is that in my case, this is for me, I do care a lot about how logical the statement reads, because often people care a lot about, let's say, all those scores from the standardized testing or the GPA and whatnot, because it's a bit easier for people to know where they are in terms of numbers. And then they often tend to overlook the importance of writing the statement in a way that appeals to the readers. So spending enough time on writing the statement so that the readers like me, can easily get the sense of what are the things that excite the applicant most, so that I can also be excited about that applicant as well. So yeah, those two things.
I definitely agree with that. I think, when you're putting your application together, your scores are your scores. And something definitely to put a lot of focus on is a thoughtful statement of purpose. It's important for us to know your interests. It's important for us to be able to gauge, your ability to present your ideas. Reference letters, also very important. It helps us really kind of evaluate your passion for the subjects. Also, potentially, if you have reference letters that can allude to your problem solving skills and things like that, that's also really helpful.
I feel like this question kind of maybe shows off my personal bias, but I've always been a terrible student. So, for me at least, I don't really pay much attention to grades or standardized test scores. But maybe to echo sort of the other panel said, certainly prior research where can we actually see, oh, here's the science that you've done and here's how you wrote it up, matters a lot to me. I love browsing through applicant GitHubs. I feel like that gives me a really great idea on what their actual kind of what's going on under the hood and what the work looks like. And I kind of echo the other panelists. I think rec letters, like strong letters of recommendation, especially from people that we know personally, usually count for a lot.
Great. Thank you everyone for your time then. Feel free to log off, or if you guys want to hear what the students are gonna say in the panel, stay on. But let me share my screen so I can introduce the students. Great. So today we have with us 4 students who are currently in the CDS PhD program on the, and actually, yes, we have all 4 here, just checking, who are in the CDS PhD program in various years. And Arda was already given a call out earlier today. So if the students can please introduce yourself, your background before joining the PhD program, your general research interests, and which faculty you are currently working with. And I will start with Arda, please.
Hi, everyone. I'm Arda. I'm a first-year PhD student at CDS Medical Track. I'm working with Dan Sodickson and Sumit Chopra on representation learning in MRI. I did my undergrad and master's in electrical engineering. During my master's, I was working at the intersection of signal processing, information, and coding theory.
Thank you, Arda. Lavender?
Hi, I'm Lavender. Before CDS, I was a double major in electrical and computer engineering and math at Carnegie Mellon.
And Lavender, what are you working on? What are your research interests right now? Who are you working with?
Yeah, sorry, I'm co-advised by Eric and Kyunghyun. My research interest is representation learning. More specifically, I'm interested in using machine learning to understand clinical notes.
Thank you. Haresh?
Hi, I'm Haresh. I'm a second-year PhD student here at CDS. Before this, I did my bachelor's in mechanical engineering, and before starting my PhD, I was doing the master's in the same program here. So right now, I'm working on self-supervised learning with medical images and also some electronic health record data. I'm advised by Professor Kyunghyun Cho and Professor Jiang at the medical school. So,
thank you, Jack.
Hi everyone, my name is Jack and I'm the third year's PhD student. And I'm now working with Professor Nagas Razabian and Professor Lavender Granda. And before I being the PhD program here, I was doing my undergrad in maths and my master in CDS as well. And my recent project focuses on using the histopathology images for cancer diagnosis, prognosis prediction, and mutation prediction. Because the histopathology is really large, so we use a lot of like self-supervised learning and weakly supervised techniques to solve these problems.
Thank you, Jack. So I want to see what is a project that you guys are currently working on. If you can elaborate a little bit about the project and what the goals are. Arda, do you mind starting? Or?
Yeah, so I'm working on a project which is called Everywhere Scanner. So basically, we're applying state-of-the-art representation learning into magnetic resonance imaging to get a feeling of new methods possible in image reconstruction specifically.
Lavender?
Yeah, so I'm working on a project called like NYU Tron. So it's a transformer, like it's a BERT model pre-trained from scratch using 10 years of clinical notes or around 4 billion words from the NYU electronic health record. You can call it Neutron just for brevity. So the goal is to help doctors make better discharge decision or so if you're not familiar with that, basically doctors need to decide when to send a patient home. If they are sent too early, then maybe they're not treated. So they will come back and be even sicker. If they're sent to home too late, then they're occupying valuable hospital resources that could be used to treat other patients. So the timing is really important. And we use this custom pre-trained model and fine-tuning it on readmission prediction tasks. And what we found is that it's better than the median physician, and it's better than models that relies on structured data rather than text.
Haresh?
Yeah, so right now I'm working on applying self-supervised learning to improve diagnosis in osteoarthritis. So for people who don't know, osteoarthritis is a progressive disorder where it happens in different knee joints. So right now we're particularly looking at knee. So where your cartilage kind of recedes over time, and then eventually you can't walk anymore and you need to do a total knee replacement procedure. So we would ideally like to diagnose this as early as possible, and then so that you can make lifestyle changes, so that it eventually doesn't reach that point where you need a very expensive surgery. So the problem here is that typically we have small data sets to train on, and we would ideally like to use a lot of knee radiographs and hopefully learn some stuff from that. So if you don't know, in the case of natural images, for example, like ImageNet, which is like a popular benchmark data set, typically people achieve this self-supervised learning by teaching these models different kinds of invariances. They said, tell the model that you should be invariant to rotation. You should be invariant to, like random cropping. You should be invariant to some, high-level augmentations like multi-crop and things like that. And they hope that, okay, but being invariant to these augmentations, the model effectively learns a bit of, representations before even seeing any labels. And that's something that has shown to be really effective in the case of natural images, but in medical images it's not quite as simple as that. So we actually from the first set of experiments that we did, we find that teaching these invariances doesn't actually doesn't actually help in our downstream task, where we would like to gauge on how bad the knee actually is. So my work has primarily been understanding and learning what kind of invariances that could help improve these tasks. And yeah, that's what I'm working on right now. Thank you.
Jack?
Yeah, thanks. So I briefly introduced my recent project, and so more concretely, I'm working on histopathology images, and the histopathology images are usually really large. They contain gig pixels. So you have to crop them into small tiles to fit the memories. However, usually we only have the slide level label for histopathology images. there's no like pixel level annotation in most cases because that requires a lot of expertise and it will be very expensive to annotate them. So which means that in this case, we have like far more data than the labels. So therefore, we are focusing on like using self-supervised learning and weakly supervised learning techniques to train the representation for each tile, then put them together to do the prediction. So in this case, we will meet a lot of problems. For example, like for the histopathology scanned by different devices, you may have like different batch effect we call. That means they have like some fundamental bias between different devices, and we need to reduce these biases. Also, just mentioned, the self-supervised learning problem, like it can apply pretty well in the natural image, and but it may have some problems in the medical images. For example, like they may be not discriminative enough, and we need to use the weakly supervised learning label to help the network to fine-tune these representations. So this is basically what's the recent project I'm working on.
Thank you, Jack. So we have a couple of questions in the Q&A. Jordan asks, how did your research interest change from when you applied to when you actually started researching? So I'm just going to open the floor and whoever would like to take the question. Have your research interests changed since you've started?
It's more like I knew broadly what I wanted to do, like work on these kind of like interesting diseases, but you do have to like pick something specific in that, so you can do rotations here for like a few semesters, like a couple of semesters, and you'll understand okay what you actually want to do, and then you can pick some specific problem and start working on that. So yeah, but broadly it's been the same. Like I would say.
Yeah, from my side, when I was doing my master program, I did some like research in the EHR, like electronic health records. But after that, when I was my first year of my PhD program, I met some like good collaborators and good opportunities in histopathology, and I found this kind of data set is kind of quite interesting. There can be a lot of like new machine learning method can be applied on that data set. So I shift my research interest a little bit from the EHR to the medical imaging.
Yeah, I think my research interest also changed. Back in undergrad, I was working on graph signal processing. And then in my senior year, I started a project to apply graph signal processing to a biomedical problem. And I found that not just working on math, but also have real world impact is really fun. So that's why I ended up being a medical track student here.
Thank you. Another question is, what data science techniques do you use most often or that you find most valuable? Are there any specific data science techniques that fall into this answer, or?
From my perspective, for like technical part, I feel like the PyTorch is most important in my daily research. But like anything else is that the understanding of like the metric for different problems, I would say. Before you like starting working on some project, you should like understand like how to evaluate first. Otherwise, it will become like blind searching before you like having a good effort into that project.
So there was a question which I think someone had answered. Yes, Arda has answered us. Someone was asking about attending class remotely or on campus, but generally speaking, how is CDS PhD student life? What are your daily schedules like or weekly schedules like? And I know it varies from year to year. So maybe Arda, as a first year student, can start.
Yeah, I'm taking 2 courses. So like 4 hours a week, I need to be around the campus. And then during meetings with advisors, I prefer face-to-face meetings. But otherwise, I can work remotely as well.
Yeah, I'm not doing any courses this semester, so it's just research. But I do come to the office every day, pretty much every day, and yeah, I also like meeting my advisors face to face. It's pretty fun, I think, in comparison to at least. And I don't want to compare other programs, but yeah, it's nice here in New York, and you get to do other stuff as well. It's fun.
Yeah, I usually spend like 2 days at CDS, so near Washington Square Park, and 3 days at the hospital. That way I can talk to like both clinical people and I guess computer science people. Yeah, and then I'm taking only 1 class this year. It's really good that it only takes 1.5 years to finish all your course requirement, and then you're free to do whatever research you want and not worry about homework. I guess that's one of the perks of the CDS program. My husband is in Canton School of Engineering, and it takes him 3 years to finish the course requirement.
So I'm not taking any course this semester, and I usually spend like 3 days at home and 2 days at CDS.
Thank you. And just a clarification is, even though you guys are not taking classes, you are enrolled in independent studies and research rotations. So you still have to complete, students who are in the program still needs to complete 72 credits of coursework. So prospective students regularly ask us, based on my background, X, Y, or Z, is this program appropriate for me? Thinking back to your experience, what was it that made you realize that this program, the CDS medical track program, was appropriate for you?
Yeah, so for me, mainly I got into like other biomedical programs. But the thing is, like in those, everyone in the cohort will be working only on only on like medical applications, and all your advisors are only like primarily focused on medicine. But that's not really the case here. You have people working on LP, you have people working on like proper theory, you have people working on ethics, like fairness and things like that. So you kind of have people doing all different kinds of things, and you can get their advice and also incorporate that into your research. I felt that could be something that's very valuable, and yeah, so that was one of the main reasons why I started this program.
Arda, since you just went through the process most recently, like what was it that attracted you to the CDS program?
Oh, like so my background was, as I told you, signal processing, and that matches the biomedical part, like MRI. To be specific, magnetic resonance imaging is heavily based on signal processing, and then the information theory part was related to the data science, machine learning in general. So I find that interesting, and that is the primary reason why I wanted to pursue a PhD in data science.
Thank you, Arda. So what were your expectations going into the program? How has the reality differ or matched your expectations? Did you guys have any expectations coming in, like thinking that you won't have a life, I guess, or vice versa?
Yeah, I was in the master's program. Yeah, so I sorry.
Yeah, Harris, you can go. Harris, you can go first.
So yeah, I was in the master's program, so I kind of knew how it is, and it's generally better. I'd say like you can have a life here, so it's not a problem. But it's for me, it's like a little bit more work than a full-time job. Is what I would summarize this, as, which is not bad at all.
Yeah, so for me, I have similar situation with Haresh because I was master student here before. So I kind of have already some like research experiences in CDS. So I would say basically just because that I have the similar experience before, so I don't have like a huge surprise like in what the life will be like here. So in general, everything's fine. Like the advisors are usually friendly and usually the workload are handleable. And I've already also completed most of the coursework, so there will be not a huge stress. And the only difference is I feel like is that the freedom, the PhD program have placed you in a more freedom to research your own interesting ideas instead of like master research, where usually it's more like a short-term small project. So this is what I prefer to enroll in a PhD program.
Thank you, Jack. So for applicants who are preparing the application for CDS, are there any advice that you would have for them as they are preparing the applications, whether it's how they approach faculty for a letter of references, who they should approach, or how they should write their statement of purpose?
So I got this advice from, like, when I was writing the application, I got this advice from my mentor. He told me to have less fluff in my application, and that means, you know, no childhood dreams, but more focus on like what kind of claims you're making and what kind of evidence you have to support it. Like, for example, if you want to make the claim that you are a fast learner, maybe you can show evidence by your previous experience, like how you learn some tools really quickly and applied it in that project in a very short time frame.
Yeah, and also everyone told me to start the SOP from your undergrad, like not go before that, and primarily like like centered around the works, as Lavender said, like centered around the works that you've done, and yeah, and just not list the works like one after another, but rather like try to make up a story and how it how it's like led you there. That would be, I think, a nice.
Okay, so thank you everyone for your time today. I'm sure the attendees got a lot out of the panelist session, and we'll have this recording up on the website as well. So people who weren't able to attend would be able to hear our comments. So I am going to share my last slides. So I just want to thank you everyone for joining us today. These slides will also be up on the website likely early next week. So you can check our website. There's a webinars page. And I also list some links here to learn more about the PhD program as well as the medical track, and then a FAQs page. If you have any unanswered questions, please email us at cds-admissions@nyu.edu. Also follow us on social media. We usually announce when our applications are opening, which they're open right now on GSAS Application Resource Center, and other information as well. So, and thank you again, panelists, for attending today on a Friday morning.
Thank you.
Thank
Thanks for
you.
the inviting.